All right, welcome to another deep dive. This time we're looking into this earthquake swarm happening in Ethiopia.
Yeah, lots of shaking going on over there.
We've got a scientific newsletter on it, plus a couple of research papers to really dig into it.
Excellent. Sounds like fun.
So, you've probably heard of the East African Rift. That's where all this is happening.
Oh, yeah, definitely.
It's basically this zone where the African continent is literally splitting apart.
Right. Pulling itself in two.
So, earthquakes aren't unusual there.
Nope. Happens all the time.
But this swarm is something a little different. It's in the Afar Triangle.
Okay.
And scientists are interested because it's so much more intense. And it's gone on for longer than anything they've seen in the past 25 years.
That is interesting.
Yeah, so what's going on with this swarm? What makes it so unique?
Well, we're seeing a cluster of earthquakes. 55 of them have been above magnitude 4.
Wow.
And 2 of them even hit magnitude 5.
Okay, that's starting to get serious.
Yeah, that's strong enough to be felt even 100 kilometers away.
Wow, that's a long way.
Yeah, it's pretty impressive. And it's not the typical pattern where you have a big quake and then smaller aftershocks.
Right.
It's a sustained activity, so it suggests that something else is going on beneath the surface.
Okay, and I'm going to guess that something else has to do with volcanoes.
You got it. The leading theory is that this swarm is driven by magma. So molten rock moving around underground.
Yeah.
It's kind of like imagine a giant plumbing system down there.
Okay, yeah.
And when magma forces its way through those cracks and fissures, it generates pressure, and that pressure can fracture the rock.
Right.
And then that fracturing is what we feel as earthquakes.
Okay, so basically the Earth's internal plumbing system is springing a leak, and all these earthquakes are the tremors from those leaks.
That's a great way to put it.
So are there any particular volcanoes that we should be worried about in this area?
Well, there are 2 volcanoes near the swarm, Fentail and Dofan.
Okay.
Fentail last erupted back in 1820.
So it's been a while.
It has been a while, yeah. But Dofan's a bit of a mystery.
Okay.
It's nicknamed Smoking Mountain.
Oh, that sounds ominous.
Yeah, it hints at some activity, but we don't have a clear record of its past eruption.
So we don't really know what it's capable of.
Exactly.
So the big question on everyone's mind is, with all this shaking, could it lead to an eruption?
I mean, of course, that's a possibility.
Right.
But it's important to remember that magma often intrudes into the Earth's crust without ever reaching the surface.
Right, so it doesn't always mean we're going to see lava spewing out.
Exactly. It can cool and solidify underground, and it forms what are called dikes.
Dikes, okay.
Yeah, these are basically giant sheets of igneous rock.
Yeah.
They can be kilometers long.
Wow, so even without a dramatic volcanic eruption, this magma could still be reshaping the landscape underground.
Absolutely. And there's actually a precedent for this kind of large-scale intrusion. It's really relevant to what we're seeing now. Back in 2005, there was a similar swarm in northern Afar, and that led to the formation of a dike that was 80 kilometers long and 8 meters wide.
Wait, 80 kilometers?
Yeah.
That's like the length of a small country.
Massive.
How do they even figure out that a dike had formed?
Well, scientists used satellite radar images
Okay.
to detect subtle changes in the ground shape. It's called INSAR.
INSAR.
Interferometric synthetic aperture radar.
Okay.
And the images clearly showed the ground bulging upwards as the dike was intruding.
Oh, wow. So they basically saw the Earth's skin being stretched and warped by this underground intrusion.
Yeah, pretty much.
That is wild. And I'm guessing they're using the same technique to monitor this current swarm?
You bet.
And what are they seeing?
Well, they're seeing significant ground deformation right where the swarm is happening.
Yeah.
We're talking about roughly 40 centimeters of near vertical motion.
That's like the height of a textbook.
Yeah, it's a lot. The ground is literally being pushed upwards.
Okay, that's definitely a red flag. But how does that compare to the 2005 event? Was the deformation back then even greater?
That's a good question. It's tough to say. We don't have all the answers yet. Scientists are still, crunching the numbers, comparing the data from both events.
Right.
What we do know is that the 2005 dike was exceptional in its size and how fast it formed.
Yeah.
It stretched for 80 kilometers in just a few weeks.
That's incredible.
It's pretty mind-blowing when you think about the forces involved.
Yeah, it's almost like watching the Earth breathe in slow motion with these massive movements happening beneath the surface.
It really is quite something.
But how can they tell if a dike is forming now?
Oh, good question.
Is it just the ground deformation, or are there other things they're looking for?
Yeah, so ground deformation is a major clue, but it's not the whole story.
Okay.
Scientists are also really closely monitoring the seismic activity.
Right.
They're analyzing the patterns of the earthquakes, the locations,
Yeah.
the depths. All those details can help them create like a 3D picture of what's happening underground.
So it's like they're using the earthquakes as these tiny little probes to map out the magma's movements.
Exactly. And they're also looking for changes in gas emissions.
Oh, right, because volcanoes release gases.
Yeah, things like sulfur dioxide and carbon dioxide.
Okay.
And an increase in those emissions or a change in their composition could indicate that magma is rising closer to the surface.
So it's like the volcano is sending up smoke signals, warning us that things are heating up down below.
Yeah, that's a good way to think about it.
Are they seeing any of those changes now?
There have been some reports of increased gas emissions in the area.
Okay.
But the data is still being analyzed.
Right.
It's tricky because those emissions can be affected by a lot of things, weather patterns, human activity.
Yeah, of course. Okay, so they're monitoring the earthquakes, the ground deformation, the gas emissions.
It's all connected.
All these pieces of the puzzle.
Mm-hmm.
But at the end of the day, is it even possible to predict what's going to happen?
That's the million-dollar question, isn't it?
Can they say for sure whether or not there will be an eruption?
Well, volcanic eruptions are notoriously difficult to predict with absolute certainty.
Right.
It's a bit like trying to predict the weather.
Right.
We can use all the data we have to make educated guesses, but there's always an element of uncertainty.
So we're left with this nail-biting question. Eruption or no eruption?
Exactly.
And I imagine that's got to be pretty unsettling for the people living in the region.
Oh, absolutely. It's important to acknowledge the human element here.
Yeah.
For the people who call this area home, this isn't just a scientific curiosity.
Right.
It's their lives, their livelihoods, their communities at stake.
Yeah, I can only imagine the anxiety and uncertainty they must be feeling. What kind of advice are scientists and authorities giving to people in the area?
Well, the most important thing is to be prepared. That means having an emergency plan, knowing evacuation routes, having a go bag ready with essentials like water, food, medication.
Right.
And it's also crucial to stay informed, follow updates from local authorities, disaster management agencies.
Makes sense. Better to be safe than sorry.
Absolutely.
Especially when you're dealing with something as unpredictable as a volcano.
Mm-hmm.
But even with all this immediate concern about a potential eruption, there's a much bigger picture to consider here.
You're right.
We're talking about a continent splitting apart.
Yeah, it's easy to forget about that when you're focused on the immediate danger.
So let's zoom out for a second.
Okay.
Talk about the bigger picture. What does the future hold for this region as this rifting continues?
Well, if you could fast forward millions of years, you'd see a completely transformed landscape.
Okay.
As the rift widens, new land will be formed. Molten rock welling up from deep below will solidify, creating fresh volcanic rock and potentially even volcanic islands.
Oh, wow.
Imagine a chain of volcanic peaks rising out of the African plains like a mini Iceland.
Wow, a mini Iceland. That's a pretty epic image. So we could be witnessing the very early stages of a process that will one day create a whole new ocean basin.
Potentially, yeah. It's a slow process, but it's happening.
I mean, that's just mind-blowing.
It really is. And what's happening right now with this swarm, it's just a tiny but fascinating piece of that much larger puzzle.
This deep dive has definitely given me a new perspective on the power of geological time. It makes our human lifespan seem like a blink of an eye in comparison. But I have to ask, if this rifting continues, could it eventually lead to the African continent actually breaking apart?
That's the big question, isn't it? And scientists are actively studying and debating that.
Okay.
There are different models and theories about how the rifting will progress.
Right.
But it's a slow motion process unfolding over millions of years. It's not like the continent is going to suddenly crack in half tomorrow.
Okay, so we're talking about a gradual stretching and thinning of the Earth's crust over vast stretches of time. But what does that mean for the people living in this region? Will they eventually be living on a completely different landmass?
It's fascinating to think about, isn't it? Millions of years from now, the map of Africa could look drastically different.
Yeah.
Imagine new coastlines, new islands, new land bridges connecting to what is now the Arabian Peninsula.
It's really hard to wrap your mind around those timescales.
It is. It's a story that's still being written, and this current seismic swarm, it's just giving us a glimpse into one of its most dramatic chapters.
But while the future is full of possibilities, we still have this pressing question about the present. Will this current swarm lead to an eruption, or will it fizzle out without a major event?
We've talked about the challenges of predicting volcanic activity, and honestly, we just don't know for sure.
Right.
But what we do know is that scientists are watching closely, gathering as much data as possible, and working to understand these complex forces at play beneath the surface.
And that's where this deep dive takes a turn into the realm of the unknown. Will this swarm be a precursor to something bigger? Or will it fade into the background as the Earth continues its slow, steady process of reshaping itself? But even if this swarm doesn't end up causing a major eruption, it's a good reminder that the East African Rift is a really active place geologically.
Yeah, for sure. So this isn't just a random event. This is all part of a bigger story, one that's been playing out for millions of years.
Millions, yeah. And it's a story that's not over yet. Scientists are still learning new things about how the rift is evolving, how the magma moves under the ground, how all these forces shape the landscape, and how it all affects us humans living on top of it all.
It's exactly.
It makes you realize that we're just temporary visitors on this planet.
Yeah.
We're living on a world that's constantly changing, and every now and then we get a glimpse of these powerful forces that are at work under our feet.
Yeah, and I think that's a big takeaway from all this. It's not just about this one swarm or even just about volcanoes. It's about stepping back and seeing that bigger picture, those long-term processes that are shaping our planet and our place in it.
Right.
It's humbling.
Absolutely. Well, for you listening in, I hope this deep dive has given you a little bit of a new understanding of the East African Rift. It's a story of continents being torn apart, of oceans being born, landscapes that are always changing.
Yeah, it's pretty wild.
It really is. Be sure to like and subscribe to our channel.
We'll be back soon with another deep dive.
Until then, keep learning, keep exploring, and keep asking questions.
See you next time.